Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, for this lecture is for week 7. Title is emulsifier. So we can call it as a emulsifier, or the chemical terms sometimes we call it as surfactant. Okay, so emulsifier can be one of uh, food ingredient. So you already learn with Dr. Rumaisa on many types of food ingredients. So emulsifier is one of the food ingredients. Okay, before we proceed to the next slide, so hopefully you can imagine what is emulsifier, and then some important things about this topic is that you need to understand what is the emulsifier, and then what is the emulsion process, what are those method in which we can do the emulsification process, what are those effect if the emulsification process is not okay, what are those effect, and what are those factors that contribute to the emulsification process, and types of emulsion, that are those important subtopic that you can learn in this uh, lecture. Okay, and then what is an emulsion? Okay, an emulsion is a mixture of two or more liquids that are usually immiscible with each other. So emulsion is an mixture or final solution after we mix both oil and water using emulsifying agent, for example. So this immiscible solution refers to oil phase and also water phase. So please don't get confused between emulsion and also emulsifier. So emulsifier is the emulsifying agent. Contoh macam lecithin ataupun gelatin. So that one we call as a emulsifier or emulsifying agent. Then that emulsifier that cause emulsion to happen. Okay, so we have two main components in an emulsion. First is disperse phase, and second one is continuous phase. So how you want to differentiate these two term? So disperse, so dia berselerak disperse, and then continuous phase is dia punya medium or dia punya platform lah. For examples, oil in water emulsions, so minyak dalam air. So the disperse phase will be the oil lah. So you can see on the left side, the oil droplet in the water. So the oil droplet will be the dispersed phase, whereas water will be continuous phase. Okay, on the other side, on your right side, is a water in oil emulsion. So the droplet will be the water. So water will be the dispersed phase, and oil will be the continuous phase. Okay. So oil can be dispersed or continuous, and water also can be dispersed phase and also continuous phase. It depending on the situation line. Okay, next is types of emulsion. Okay, you just remember these two types lah. So actually we have many other types of emulsion. So this is the basic types lah. First is water in oil emulsion, and then second one is oil in water emulsions. Actually we have also water in oil in water emulsions, And then sometimes also we have oil in water in oil emulsion. So banyak peringkat So we just need to know these two types So first is water in oil emulsions. So how you want to differentiate these two types? Okay, if water in oil, so the dominant will be the oil lah. So the oil will be dominant because water droplet in oil. So the oil will be the dominant. So examples is you just remember on the example so it's easy for you to memorize. So examples is butter, margarine, cold cream, and also cold liver oil. So you can imagine the textures is much more oily compared to oil in water. Okay, if oil in water, so the oil droplet will be dispersed in the continuous phase, which is water. So oil in water, the textures or the textures is more like watery lah. So you can imagine on a like a mayonnaise. So mayonnaise is oil in water emulsions. So we go one by one lah. So water in oil emulsion on your right side. So water is the dispersed phase and oil is in the continuous phase. So sometimes referred to as an inverse emulsion. So it has a high oil concentration. So sama macam I cakap tadi. So used in butter, margarine, cooked cream, and cooked liver oil. So common water in oil, so W dash O. Emulsifier are sorbitol, stearate, polyglycerine, oil, and lecithin. So and then next is oil in water emulsion. So the oil is in dispersed phase and water in the continuous phase. So it contains a low oil water concentration. So they are mixable with water, non-greasy and non-occlusive and will absorb water. So it's dia lebih kepada watery lah. So used in moisturizing products and food products like mayonnaise. So you need to remember the examples, the food examples, so easy for you to memorize. Okay, so now you can see this picture. On your left side is oil in water emulsions, and on your right side is water in oil emulsions. So you need to differentiate this both diagram. So if we have whiteboard, I easily can draw in front. Okay, but it's okay. Uh, you see dia punya emulsifier. So emulsifier punya figure, right? It has both hydrophilic and also hydrophobic. So actually the pictures on the other slide, but it's okay. We can go to that slide after this. Okay. Tail. It has both hydrophilic and also hydrophobic. So usually hydrophobic tail. So this is the tail, the yellowish color or orange color, and then the blue color is on the hydrophilic phase. So that hydrophilic in this condition for oil in water emulsion, the hydrophilic head will attach to the water medium, whereas the hydrophilic, so hydrophilic will be oil it likes to oil lah, dia suka pada oil and this hydrophobic tail will be attached to the oil face. Okay, how about water in oil so it will be opposite dia punya tail hydrophobic tail will attach to the continuous phase of the fat, whereas the dispersed phase, so here this condition, this first phase dia punya water droplet lah, so the hydrophilic head will be attached to the water phase. So you kena tahulah hydrophobic and hydrophilic head and also hydrophobic tail. Okay, next we go to on the preparation of emulsion. Okay, how to prepare an emulsion? So there are several types, several methods. Sorry, there are several methods in which we can prepare an emulsion. So here I just state three methods. Okay, number one is by using emulsifier. So of course, we can use emulsifier. This is the most agent, the most important agent lah in making emulsion. And then number two, homogenization. This is the physical method to make an emulsion. And then number three is sonication. Okay, and then we go one by one. Okay, number one is by using emulsifier or emulsifying agent. Okay, as you know, emulsifier contain both hydrophilic and hydrophobic end that absorb at the oil and water interface. So this is the basic thing. You should know what is hydrophilic phase and what is hydrophobic phase. So hydrophilic will attach to water, whereas hydrophobic will attach to the oil phase. So this emulsifier will reduce the interfacial tension. So what is interfacial tension? So this tension is a tension lah, the force that occur between oil and water interface. So this force dia akan menolak each other lah antara water and also the oil. So the function of this emulsifier to reduce this force. So dia akan hold the oil and also the water punya phase to become closer to each other. Okay, so this interfacial force, this emulsifier will form a protective layer around droplets to prevent collision. So examples of emulsifier are lecithin, mono and diglyceride, polysorbates, and proteins. Either way, protein, gelatin also can be one of the emulsifier as well. Okay, okay. This is some examples of food emulsifier that commonly used in various type of food and also food product. So we have mono and diglyceride, and then acetic acid ester. So bukan acetic acid saja, dia acetic acid ester. Dia ada carboxylic acid and also alcohol. And then we have lecithin, citric acid, and then we have sucrose ester, sorbitan ester, polyglycerol, and then egg yolk, and then we have egg yolk lecithin, and then we have soy lecithin, and then we have partially hydrolyzed lecithin, and then polysorbitol, fatty acid, and the salts. So basically, all these food emulsifier can comes from plant based and also animal based. Okay, method number two to make an emulsion is by using homogenization method. So this is a physical approach. So the pictures that you can see in the slide is a homogenizer. So this homogenizer, it has a probe. So probe here that attached to your samples. So they can rotate in a very high speed, 100 rpm, 200 rpm, can go to 1000 juga. So the speed This high shear homogenizer can reduce the size of the oil droplet and produce a fine dispersion. So dia cut bila pakai homogenizer ni dia akan cut the droplet. so so can lead to a more stable temporary emulsions. Why we call it as temporary emulsions? Because it is a physical approach. So since this is a physical approach, so it cannot hold those fat and water phase uh, in a consistent way lah. So dia tak kuat, as compared to emulsifier. So because emulsifier dia link chemically bonding. So kalau homogenization method is a physical bonding, so easily dia akan detach balik. So this method is especially effective when combined with emulsifier. So if we use emulsifier method and then we add with homogenization method, so they're much more efficient compared to using emulsifier alone. Okay, method number 3 is sonication. So ultrasonication wave can help break the oil into smaller droplets and form an emulsion. So yang ni pun one of the physical approach lah to prepare an emulsion. So it is useful for temporary or nano size emulsion. So kalau kita nak buat on nano size of emulsion, we can use this approach. Actually, homogenization pun can produce a nano size of emulsion. So bila nano size, so nowadays research much focus on a nano size untuk emulsion or any other synthesis punya chemical synthesis. They more focusing on a nano size because this nano size can increase the surface area lah. If you use it for food ingredients or any other application, kalau nano size biasanya much more preferable lah. So dia boleh contact with other ingredients or other samples because of the high surface area. So useful for temporary or nano size emulsion. So sama juga temporary because it is a physical approach. So however, without an emulsifier, the stability will still be limited because droplet can quickly merge again. So this approach almost same to the homogenization method. So to be much more effective, actually we can combine both using emulsifier, using homogenization method and also sonication method. First, biasanya kita mix the oil and water with the presence of emulsifier, and then we homogenize followed by sonication. It will be much more effective and the emulsion will be more stable lah. Okay, the most important criteria for the selection of emulsion is the stability. Means that kalau you works in a food manufacturers kilang makanan, then you're going to use emulsifier in order to develop new product. So apa yang penting is the stability of the emulsions dalam you punya product lah. Okay, how we want to know that the emulsion is stable or not? Okay, so this is one of the examples or simple test you can conduct dalam you punya later on QA QC dalam you punya kilang. So based on this picture, what do you understand about emulsion stability? So emulsion stability, if the stability of the emulsion to withstand the condition as it is lah. So maksudnya bila you dah mix everything, you use emulsifier and then you use homogenization or sonication approach, and then that emulsion can withstand. Maksudnya dia boleh stabilize lah, it's stable for a period of time lah. So we can check on uh, on the stability at a certain period of time. For example, 1 week, 2 weeks, 1 month, depending on the food product lah. So you can see here day one, and then until day 7 you tengok this sample bottles ada control, and also ada where you to use the samples lah. Okay, and then by time you see that the emulsion on using emulsifier, you can see the samples is stabilized throughout that 7 days of storage. And then for the control sample, you can see that it turns to separate after day 7. So meaning that maybe the control sample doesn't have emulsifier. They didn't add any emulsifier. So that solution will tend to separate after few days. So it shows that the control sample is not stable.